Remember the first time you heard about or saw the moon landing? That moment marked one of the greatest innovations in humankind: space travel. More recently, even more new innovations are being made in this field, with NASA recently announcing the Artemis missions that will send the first woman and the first person of color to space, in the moon, and eventually in Mars. But one thing that hasn't been largely considered within this mission is the effect that going on deep space missions has on the female reproductive system, which is exactly what I'm addressing in my research funded by NASA. So right now, we are protected from harmful radiation due to the magnetosphere, which is essentially Earth's protective magnetic field. But when you leave the magnetosphere, such as when astronauts go on deep space missions, they are susceptible to harmful radiation, specifically galactic cosmic radiation, which is caused by events such as galaxies colliding and emitting harmful particles. My research focuses on the emission of oxygen ions specifically, and I hypothesize that if a female mice were to be exposed to these oxygen ions, then they would experience a loss in ovarian follicles, which is indicative of radiation. In order to conduct my research, I used a microscope to analyze ovaries from mice that were exposed to these oxygen ions at 3 months old, and then their ovaries were collected 14 to 15 months after exposure. And I was blind to the treatment group, but there are a few key things that I looked for to see if the ovary was indeed irradiated or not. The first thing I looked for was the presence of ovarian follicles, which are small sacs in the ovary that can grow and mature to form an egg. I looked for healthy follicles as well as dying or atretic follicles because those can show signs of radiation. I also looked for the presence of a corpus luteum, which in a healthy ovary is a protective structure that helps to prepare the body for pregnancy. Lastly, I looked for the presence of the egg in the oviduct, which is the tube in which the egg passes from the ovary. These are my counts for an ovary from a mouse that was irradiated with oxygen ions and a mouse that was not irradiated with oxygen ions. As you can see, the purple graph shows the mouse that was irradiated with the ions, and there is very much more of the dying or atretic follicles present compared to the pink graph, which shows the mouse that has no irradiation. Along with that, here's a side-by-side comparison of an ovary that was irradiated compared to an ovary that was not irradiated. As you can see, there are many clear visual differences. I still have a few more animals to count and a few more years left for this project, but I'm already so excited because I can see where my research is going. It's going to provide foundational research to prepare preventative treatment for deep space travels. So whether that be an astronaut traveling to space or a citizen in the near future wanting to go to space travel, they are able to travel to space without having to worry about compromising their health. Thank you so much.